Hi, I'm Mr. Parker and this is question 6 on the OCR Mechanics 1 paper from June 2013. For more questions on this exam paper, click the link here or check in the video description. A particle P moves in a straight line. At time t seconds after passing through a point O of the line, the displacement of P from O is x meters. Given that x equals 0.06 t cubed minus 0.45 t squared minus 0.24 t, find the velocity and acceleration of P when t equals 0. If we want to find the velocity of a particle and we know the displacement, what we need to do is differentiate, because velocity is defined as the rate of change of displacement. How quickly is my displacement changing? So to differentiate the first term, we multiply the coefficient by 3, that gives us 0.18 and we get t squared. For the second term, we multiply the coefficient by 2, that gives us 0.9, so we get minus 0.9t. And for the third term, we drop the t to get minus 0.24. Now that we have our expression for velocity, we need to find the value when t equals 0. So all we've got to do is substitute in t equals 0. So we get v equals 0.18 times 0 squared minus 0.9 times 0 minus 0.24. The first two terms will disappear because we're multiplying by 0, leaving us velocity equals minus 0.24 meters per second. To find acceleration, we need to differentiate again. We need to find dv dt, because acceleration is defined as the rate of change of velocity, how fast the velocity is changing. So over here we've got our expression for the velocity. All we need to do is differentiate this. So for the first term, multiplying the coefficient by 2 gives us 0.36t. For the second term, we drop the t and get minus 0.9, and the third term doesn't have a power of t, so that will disappear. Again, we're interested in what's happening when t equals 0, so substituting that in gives us 0.36 times 0 minus 0.9. So the acceleration is minus 0.9 meters per second squared. In part 2, we need to find the value of x when p has its minimum velocity and the speed of p at this instant. Up here we've got our expressions from part 1, and if we think about the velocity and drew the graph of it, because the largest power is t squared, it will be a u-shaped parabola. And to find a minimum point on that graph, what we would do, if you remember from core 1, is differentiate it and set dv dt equal to 0. So that's what we're going to do now. Remember though, we've already found dv dt, that became a. So what we have here is the expression for a, 0.36t minus 0.9, equals 0. Notice how we're not trying to find when the velocity is 0, because the minimum velocity could be when the particle has negative velocity. So solving this equation, if we add 0.9 to both sides, we get 0.36t equals 0.9, and then dividing through by 0.36 will give us 2.5. In some cases, just setting dv dt equal to 0 is not necessarily enough information to definitely determine that it's a minimum point. If our original curve changed directions more than once, there may be a minima and a maxima, in which case we'd need to find the second differential. However, in this case, because we know the shape of this is a parabola, a u-shaped parabola, there's only one turning point and we know that that is going to be a minimum, so there's no need to do it for this question, but quite often you may need to do that. Now that we've found the value for t, we need to use that to find the value of x and the speed of p. When t equals 2.5, the displacement x is given by 0.06 multiplied by 2.5 cubed minus 0.45 multiplied by 2.5 squared minus 0.24 times 2.5. If we put that into our calculator, we get minus 2.475. For the speed of p, we get v equals 0.18 multiplied by 2.5 squared minus 0.9 multiplied by 2.5 minus 0.24. And that gives us negative 1.365. However, we need to be careful here because the question is asking us for the speed of p at this instant. Here we found the velocity, and we know that speed must never be negative because it's a scalar quantity. So all we need to do is flip the sign of this and say that the speed is 1.365 meters per second. So our final answers are negative 2.475 for the value of x and 1.365 meters per second for the speed of p. In part 3, we're interested in finding the positive value of t when the direction of motion of p changes. Well, if you think of a particle travelling in a particular direction, in order for that particle to then travel in the other direction, it has to first slow down until its velocity is 0 and then change direction. So if we want to find out when it changes direction of motion, we need to find out when the velocity equals 0. So all we've got to do is set this quadratic here equal to 0. Now if you wanted to, you could go ahead and solve this quadratic as it is, but I'm going to make the numbers simpler to deal with. First of all, I'm going to multiply everything by 100. That will give me 18, 90 and 24. And then I could also divide by 6. And if I do those two steps, I get 3t squared minus 15t minus 4 equals 0. Now you didn't have to do that step, and if you didn't spot it, you wouldn't lose any marks for not doing it. From here, if we label a, b and c, we get a is 3, b is negative 15, c is negative 4, and if we calculate the discriminant of the quadratic, we get negative 15 squared minus 4 times 3 times negative 4, and that gives us 273. And 273 is a surd, so it makes sense to use the formula rather than trying to factorise. So we get t equals minus b, that becomes positive 15, plus or minus root 273, all divided by 6. And if we look at the question, we're only interested in the positive value of t. And if you look at the square root of 273, that's going to be 16.5 something. So if we did 15 minus the square root of 273 and divided by 6, we'd end up with a negative answer. So we're only interested in 15 plus root 273 divided by 6. And that gives us 5.25 if we round to 3 significant figures.